All right, this is lesson 23, and this is going to be exclusively about solving the Mystic Coffee problem. And I want to go through this quickly. We've already talked about the Mystic Coffee problem, but then just as a review, as you'll remember, we had four different coffees, Brazilian mocha, Colombian, and mild, and those were put into three different blends, the special, dark, and regular. And remember, in terms of our format, similar to a transportation, but for this blending problem, the Brazilian could go into the special, Brazilian could go into the regular, Brazilian could go into the dark, and that would be the same for each one of our respective coffees. And so again, all the way down to the mild could go into the special, mild could go into the dark, and certainly mild could go into the regular. So remember, therefore we had 12 different decision variables, and then in order to construct our objective function for each one of these combinations, we had to calculate the respective profit per pound, and again for any Brazilian that went into the Colombian, the profit per pound was $4.50 because we subtracted $2 from $6.50, and that was true all the way down to the case where we had the mocha from the regular, and of course the net profit was $1 per pound, and so forth. And we did that for all 12 of those respective decision variables. Then we had two different categories of constraints. The first set of constraints were our supply constraints, where we had 110 pounds of Brazilian, 70 pounds of mocha, 80 pounds of Colombia, and 150 pounds of mild. So 110 of Brazilian, 70, 80, and 150 respectively. And of course, we knew that the sum of the amount of Brazilian that went into the special, dark, and the regular all had to be less than or equal to, in this case, 110 pounds, and so forth for every one of our constraints. So some of these three had to be less than or equal to 110 pounds, and we had four of those constraints. Then we had the constraints that were the blending constraints, where we had specific amounts of coffee in order to reach certain taste standards, blending standards, and again, those 6 individual constraints turned out to be of the form, this type of form. Hopefully you've had the time to go through and calculate and derive all of those constraints. And after doing so, that would have led us to this complete formulation, where we have our 12 decision variables, all combinations of Brazilian, mocha, Colombian, and mild, with respect to the special, dark, and regular. We had our 12 terms in our objective function, and of course we want to maximize the profit. Then we have our 6 constraints for our blending constraints, our supply constraints, and then of course, as always, non-negativity constraints. So this was the full formulation for the Mystic Coffee problem. Now, what I want to do is spend the rest of the time for this video going through the solution and showing you some different ways to, or a way to solve, to look at this problem, because there's some key things and some important things about how you organize a spreadsheet for a problem, it's not a huge problem, but for a larger problem like this. So let's look at how we would do this. Okay, so we're going to take this formulation. Hopefully you have a copy of that, and I'm going to go to the Excel spreadsheet that I've got set up associated with this. All right, now so here's the spreadsheet. Now you'll notice, I want you to notice first of all that I've color coded these values, and actually I should take these and to be consistent in color code these cells. So anything that's a yellow cell is a data input cell. And I need to put this as yellow too, so apologize about that. These are all data inputs, and actually these cells are data inputs too. I'll complete that. Okay, now I've got this correct. Actually, these are zeros. Okay, so all of these yellow cells are data input cells. And you'll see in each one of these, it's just a number. All right. In any of the green cells, that's going to be where I'm going to input formulas. Let me get this correct. So any of these green cells, that's where I'm going to have input a formula, and you'll see what those formulas are here in a second. Any of the blue cells, which are here, are our decision variables. And you'll remember this cell, D4, represents the number of pounds of Brazilian coffee that goes into the special coffee, special blend. All right. So let's begin to see how these are organized. This is the decision variable cell. They're going to be all left blank. This is I'm going to go now over to the profit cell, and you'll notice what we have is inputs. We have the cost of the Brazilian, and we have the selling price of the special. All right, so this is a special selling price, dark selling price, and the regular selling price. So in this table here, we want to calculate the net profit that's going to be associated with the Brazilian that's put in the coffee. Now remember back to our diagram, how we did this. So in the future step that I want you to anticipate is we're going to take this cell and multiply it by the amount of, this is the amount of the Brazilian that goes into the special, times the profit of the Brazilian that goes into the special. And then that's going to become part of our objective function, or our profit equation. All right, so how are we going to do this? Well, of course, we're going to take, this is going to be a formula, equals the value that's in this cell, which is 650 for the special, minus the cost of that Brazilian, which is there, and of course that's going to be 450. That's going to be a little bit hard to read. Let me make that black. Okay, so the cost, the net profit is 450. Now what I would like to do is to be able to drag this formula and just fill up. Well, I can actually do that, but I need to do a couple of things to this formula. Is I calculate, if you calculate this next cell you want, for the selling price, you want the column to stay the same, but the row, excuse me, you want the row to stay the same, but the column to change. And for this one, you want the column to stay the same, but the row to change. Or if you were to anticipate, if you were moving down, you'd want this, the column to stay the same. So if we fix our, use our fixed references, and I'm going to highlight M3. So we said we want the row to stay the same, but the column to change. So by entering F4 from your spreadsheet, first it'll add 2, then it's going to say, it's going to put the dollar mark in front of the row because it's row number 3. The row is going to stay the same. So that's good. Then you want to do the same thing for the cost, because in this case, you want the column to stay the same, even if the row changes. So we want to put the dollar mark, it's dollar mark, $2 marks, and then the dollar mark in front of the row, and then the dollar mark in front of the column, and then the dollar marks go away, and it rotates through. So this is where we want to be, dollar mark L4. And let's see if I've done this correctly. So if I drag this across, it should calculate this correctly. So what should be 325 in this cell and 175 in this cell. Let's see if I've done this correctly. Okay, good. Now if I've done this correctly, when I drag this down, this should be 275 minus 650. That's 325, I believe, or 375. 375. Okay, and you can check it's 650 minus 275. So that's correct too. All right, so now we can actually take all of these and just drag these down. And now we've got our values, and you can check those. Now, I know that was quick. Go back and convince yourself. But again, you don't have to do this. You can just do that for, you can do this for every cell that you want to do this individually. So in other words, instead of having the dollar marks here, you could just enter in the formula directly, 650 minus 275. So either case, and you see there's an indicator there that says, well, that's how you've calculated that formula is different than above. So let's make that correction. All right. So here we go. Now that's important because now we can, for our objective function, and let me in this that's going to be in this cell. And for that objective function, and I'm going to calculate, I'm going to take the sum product of our decision variable cells with our profit cells. And let me put this format back correctly with our profit cells. And so there's a one-to-one correspondence with this. And so the profit function that needs to go in here, the easiest way, there's many ways to do that, but the easiest is equals sum product of our decision variable cells with the profit cells. Okay, and so now, right now, there's 0, but let's see if we put 1 pound or if we put 10 pounds of Brazilian into the special, our profit's $45, and so that works. Yeah, and if we put 10 pounds of mild into the regular, that should be $20.50 a profit, and it is. Okay, so that formula works. And so this, just to be clear, I'm going to take this, I'm going to copy that, and I'm going to enter that into that cell. Escape. And so that's our sum product function. That's our objective function. Okay, so now let's go forward and let's look at our functions that we need for our supply, our coffee supply. So if you'll notice, we've got 110 pounds of Brazilian. Well, all of the Brazilian that we use will be in these 3 cells, because each one of those cells represents the pounds of Brazilian that are in special, pounds of Brazilian in dark, pounds of Brazilian in the regular. And so this is just going to be the sum of these 3 cells. So that sum is going to be the total amount of Brazilian that's used. And of course, we want to make this less than or equal to 110 pounds. And that's going to be the same for each one of our other respective sum of the mocha used, just those 3 cells, and the sum of Colombian used, and it is the sum of mild used. So now these are the functions for our coffee. And so I'm just going to put this is going to be equal to the sum of ... Those are sum functions in each one of those cells. All right. Now here's one I'm going to add, a function that I'm going to add in, but this is not required, but this is a function that I'm going to add in. Well, no, because what we want to do at the end is we want to be able to know also how much special coffee are we making, how much dark, and how much regular. And so hopefully you can anticipate the total amount of everything that's in this column are the total number of pounds that of special that we're making. Now there's not a constraint, and so we don't need to worry about a constraint, but we do want to know from a practical perspective how much special blend is going to be made, how much dark is going to be made, and how much regular blend is going to be made. And then just so we balance, I'm gonna make sure that in this cell I'm taking the sum of all the coffee that's made, and in this cell I'm taking the sum of all the coffee that's going to be used, and we'll see at the end that this will all be in balance. All right, saving that. All right, so now we've got functions here, we've got functions here, we've got functions here, and our last places where we need function are going to be in these cells, and these are going to be our blending cells. And the way I've organized this, you'll notice I've put the coefficients of each one of the requirements in this column. So again, in order to satisfy the 40% of Colombian into the special, these are the coefficients that are required. And what I would ask you to do is to go back and check and verify that each one of these is correct. And I assure you that it is. Now, the reason that I've organized it this way is as follows. We've got 2 requirements for blends of Colombian and mocha in the special, 2 requirements for the dark, for Brazil and mild into the dark, and 2 requirements for mild in Brazil into the regular. And if you'll notice, the reason that I'm doing this is that these coefficients the Brazilian Mocha, Colombian, and mild that's going into special are going to correspond directly with these 4 cells. And so in this cell, as you might imagine, I'm just going to use another sum product function. I'm going to take the sum product of these cells with all of the coffee that's going into the special. Okay. Now, there's a lot of different ways that you can do this. You can also, I'm just going to do this one as an example down here. I can also calculate 0.4 times, oops, equals 0.4 times this decision variable plus 0.4 times this decision variable minus 0.6 times this decision variable plus 0.4 times this decision variable. That'll end up being exactly the same thing. Or similarly, I could go, this is this cell times this cell, which is our 0.3, plus this cell times 0.7 plus this cell times 0.3 plus this cell times 0.3. And we see that these will end up having this same value. Let's finish this. Entering these functions, and because this is going to be equals sum product. And again, you'll notice it's Mocha that's going into, this time Mocha that's going into the special. And this is going to be dark, or excuse me, the blends that are going into the dark. Oh, didn't, because I don't have undo that. Okay. And this is E14 to E, should be not 18, but to 17. Okay. And then this is going to be some product of this column that's going to go into the dark. And this is going to be equal to the sum product. And in this case, there's not a good way of these coefficients that are going to go into the regular. There's not a good way to click and drag these, but it's much, much easier, more efficient, hopefully you can imagine, to use the sum product function than to try to type all of these values in there, because the more keystrokes you make, the more likely you are to make errors. All right, so then we've got all of the functions here, our blends, and these are, for me, are just ways to remember, because this function value is going to be less than, it will be less than or equal to 0. This function value is less than or equal to 0. Of course, you can always go less than or equal to here rather than LE if you'd like. This is just a way for me to remember. This is greater than or equal to, and so forth. All right. And so I'm going to enter these constraints one by one. So now I believe we've got all the parts of the puzzle ready to go, and we're ready to solve. So here's here's what I'm going to do. Now I'm not going to show the solver because I believe you can do that. And again, I'm going to post this worksheet on Solver, and you can go in and look at it yourself. But again, we're going to go to the Data tab. We're going to go to our Solver icon at the top right of our data, and then we're just going to begin to tell Solver where everything is. All right. So the objective function value is in cell J9. It is a maximization problem, so we want to click the maximization button. The changing variable cells now are all of these, all of our blue cells, all of our decision variable cells from D4 here to F7. Then we're going to add constraints. The first set of constraints that we're going to add is the coffee used. So these 4 cells calculate the coffee that's used, and each one of those 4 cells has to be less than or equal to these 4 cells respectively. So that's one set of constraints. Then we want to add, and we're going to do these individually. So another constraint is this cell, which is the blend constraint for Columbian and special. It has to be less than or equal to 0. We're going to add another constraint. And then this cell also has to be less than or equal to 0. And then we're going to add another constraint. This cell, the Brazilian in the dark, has to be changed to the drop-down box greater than or equal to 0. The mild in the dark, I made a little error there. So this cell has to be less than or equal to 0. I'm going to add a constraint. This cell has to be greater than or equal to 0. I'm going to add a constraint. This cell has to be less than or equal to this cell. Add a constraint. This cell has to be less than or equal to 0. And add this cell has to be greater than or equal to 0. Okay, let's make sure I've got everything. And now you do want to go back. The set objective function is 9. The decision variables are correct. We've got D19 less than or equal to D20, C21, C19 less than D19. I've got 2 of these. Delete. E19, F, G, H. So C, the column C here is less than or equal to. Column D is less than or equal to. Column E is greater than or equal to. Column F is less than or equal to. G is less than or equal to. And H is greater than or equal to. And okay, it looks like our constraints. Everything is non-negative. I'm going to select simplex, and I'm going to solve. And I get the OK. I'm going to keep the solver solution, and here's your answer. So you can see that we've produced 200 pounds of special, 72 pounds of dark, 138 pounds of regular. We've used up all of our coffee, which is 410 pounds, and our profit's $1,296. Now down in these columns, you'll notice this value looks funny, but that's negative 3.6 times 10 to the minus 15. So it's a very, very small number. And this is even positive 3.5 times 10 to the negative. So it's very, very small number. And so it's essentially zero. And so all of these constraints are indeed satisfied. All right. All of the constraints are satisfied. So there's your solution. Now, one last point I want to make is the following. There could be a situation. Why do I have this data input for our constraints? Again, I like to do this because there's really two reasons. Number one, most important, if you're asked to make a change, it's easy. The easiest way to make the change. Let's suppose, for example, we made a mistake, and instead of the coffee being available, 110 is available, a Brazilian, we've got another shipment, and we have, I'm just making up a number, and I don't know what the solution, 145 pounds of coffee that's available. Well, I can make the change here, and then I can go directly to Solver and click Solve, and it'll give the answer. Whereas if I didn't do that, I would have to go into Solver and find the correct constraint and make the correction in the constraint. So here I can do that just directly on the page and not have to recreate Solver. I'm going to solve again, and so we're back to our original solution. The other thing is, the other important reason for doing it like this is that when you have these values displayed, these coefficients, you can easily see if you've made an error. So for example, let's suppose we make an error and we've entered 0.1. We forgot to put the negative sign in front. And I'm not sure what's going to happen here, to be honest. But we solve, and it came up with the same solution. But a lot of times, if there's an error, this allows you to go back and quickly check where you may have made an error, because you can quickly see, well, I left I bet this, if I put 0.7 in here, and solve, it may not even give me a solution. It did find a solution, but it's a solution that doesn't make sense, in the sense that we don't have any special made, and so you can easily find errors. And I can go back here and look, and I said, oh well, this should have been negative 0.7, not positive 0.7, and then go back and solve. And then you get the correct solution. So it's much easier to troubleshoot when you can see all of the input values, rather than trying to see those input values in these, try to find these formulas. Because if you use this and you had an error, you would have to go back in here and look at this whole formula to determine for each one of these where an error lay. So just a word of caution. I've also put another spreadsheet here, worksheet here for you to use and play with. This is the same solution. Let's suppose, for argument's sake, that instead of we made a mistake. This was 80 pounds of mocha and 70 pounds of Colombian. We got those numbers. We just transposed those numbers as we were from our supplier, and then so now we're going to solve that, And in fact, that's going to cost us a little bit of money, but it certainly will make our oops. And it makes the distribution of our coffees, our blends, different. But it does use all the coffee, so this is the best that we can do. So those are just some examples. I'm going to change this back for you so we won't get confused. But you should go in there and just play around with it and see what how it works, and convince yourself that you can use this. Okay, so that's the solution to the Mystic Coffee problem. If you have any questions, this should allow you to go in and solve your quiz. That'll be due Monday, and this is our last quiz. So hopefully you'll be successful with that. There's some questions that you need to answer with that. You can answer your questions either in your spreadsheet or on the sheet, and then resend the sheet, put that in the D2L Dropbox. So again, look forward to talking with you if you have any questions. Good luck.